Good morning, dear students. Now we see Standard 7th, the Unit 4. The title of the unit is Atomic Structure. Title of the unit is Atomic Structure. In the last chapter, we have studied anything around us as matter and is made up of molecules. The molecules are the combination of atoms of different elements or the same elements. Inside the atom, there has three particles that are protons, neutrons, and electrons. Protons and neutrons are in the nucleus, whereas the electrons are revolving around the nucleus. The proton has three gluon, two quasar, and one quark particles. Neutron has three gluon, one quark and two carbon particles. Now we see how small is an atom. An atom is 1 and 1,000 times smaller than the thickest human hair. It has an average diameter of 0.000000001 m, or that is 1 into 10 power minus 9 meter. To understand atom size with the familiar things we know, now let us find that what is the size of pencil, red blood cell, virus and dust particles. Now we see the first one is pencil size, that is 1 into 10 power minus 2 millimeter. Red blood cells, that is 1 into 10 power minus 4. Virus, that is 1 into 10 power minus 6. Dust particle, 1 into 10 power minus 7, and the atom is 1 into 10 power minus 10. That is, the atom is very small particle. Now we see about the evolution of idea of an atom. Many scientists have studied the structure of atom and advanced their theories about it. The theories proposed by Dalton, Thomson and Rutherford are now we see. The first one is Dalton's atomic theory. John Dalton proposed the atomic theory in the year 1808. He proposed that matter consists of very small particle which he named atoms. An atom is smallest indivisible particle. It is spherical in shape. His theory does not propose anything about the positive and negative charges of an atom. Hence, it was not able to explain many of the properties of substance. Followed by Dalton, Thomson proposed his theory in a different theory. He compared an atom to a watermelon. His theory proposed that the atom has positively charged part like a red part of a watermelon and negatively charged particle which he called electrons. According to his theory, as a positive and negative charge are equal, the atom as a whole does not have any resultant charge. Thomson's greatest contribution was to prove by experimentation the existence of the negatively charged particles or electrons in an atom. For this discovery, he was awarded the Nobel Prize in 1906. Although this theory explained why an atom is neutral, it was an incomplete theory in other ways. Next one is Rutherford theory. There were shortcomings in Thomson's theory. Ernest Rutherford gave a better understanding. Ernest Rutherford conducted an experiment. He bombarded a very thin layer of gold with positively charged alpha rays. Rutherford considered this remarkable and miraculous, as if a bullet had turned back after colliding with the tissue paper. Based on this experiment, Rutherford proposed his famous theory. In his opinion, -1. The fact that most alpha particles pass through the gold sheets mean that the atom consists of mainly of empty space. The part from which the positively charged particles are turned back as positively charged but very small in size as compared to the empty space. From these inferences, Rutherford presented his theory on the structure of atoms. For this theory, he was awarded the Nobel Prize for Chemistry. Now we see the Rutherford's theory proposes the nucleus at the center of an atom has a positive charge. Most of the mass of the atom is concentrated in the nucleus. The negatively charged electrons revolve around the nucleus in specific orbits. In comparison with the size of the atom, the nucleus is very small. The subatomic particles. The discoveries made during the 20th century proved that atoms of all elements are made up of smaller components that are electrons, protons, and neutrons. An electron from a hydrogen atom is no different from electron of a carbon atom. In the same manner, protons and neutrons of all elements also have same characteristics. These particles that make up the atom and are called subatomic particles. We see protons. The proton is the positively charged particle and that is located in the nucleus. It is positive charge. Its positive charge is of the same magnitude as that of the electron's negative charge. Neutron is inside the nucleus. The neutron does not have any charge. Excepting hydrogen, the nuclei of all atoms contain neutrons. Next one is electron. This is a negatively charged particle. Electrons revolve around the nucleus of the atom in specific orbits. The mass of an electron is negligible as compared to that of the proton or neutron. Hence, the mass of an atom depends on the number of protons and neutrons in the nucleus. Protons and neutrons are the two types of particles in the nucleus of an atom. They are called nucleons. The total negative charge of all and electrons outside the nucleus is equal to the total positive charge in the nucleus. That makes the atom electrically neutral. Now we see about the charge and mass of this subatomic particle. Proton. Proton is discovered by Ernest Rutherford. The symbol is small p and the charge is +1. The mass is 1.6726 into 10 power minus 27. Electron is discovered by Sir John Joseph Thomson. The symbol is small e and the charge is -1 and the mass is 9.1093 into 10 power minus 31. Neutron, that is discovered by James Chadwick. The symbol is small n and the charge is 0. That is no charge and the mass is 1.6749 into 10 power minus 7. So apart from these three, electron is very small. Now we see atomic number and mass number. Atomic number, the number of electrons or protons in an atom is called the atomic number of that atom. It is represented by the letter capital Z. If we know the atomic number of an atom, we know the number of electrons or protons in it. For example, in the helium atom, there are 2 protons and 2 electrons in orbit around the nucleus. So the atomic number of helium is 2. The next one is oxygen. Oxygen atom. In the oxygen atom, there are 8 protons and 8 electrons in orbit around the nucleus. So the atomic number of oxygen is 8. Now the next one is mass number or the atomic mass. We have seen that mass of an atom is concentrated in its nucleus. From this we can get the atomic mass number. Mass number, that is capital A, that is equal to the sum of the number of protons and neutrons in the nucleus. So the atomic mass or the mass number, that is equal to number of protons plus number of neutrons, that is A equal to P plus N. So for example, a lithium atom consists of 3 protons and 4 neutrons. So the atomic mass number, that is equal to 3 plus 4 equal to 7. In a sodium atom, there are 11 protons and 12 neutrons. Hence the atomic mass number AA, that is equal to 11 plus 12 equal to 23. When writing the symbol of an element, its atomic number and atomic mass number are also written. So for example, helium. So when we write the atomic symbol, we write the atomic number, that is in the subscript, and the mass number, that is in superscript. For example, helium, that has number 2, that is in subscript, that is atomic number, and the number 4, that is superscript, that is the mass number. Likewise, carbon, that has a 6 atomic number and 12 mass number. Oxygen has 8 atomic number and the mass number is 12. Hydrogen, that has 1 atomic number and mass number also 1. All the elements in the periodic table have the following combination of protons, electrons and neutrons. Now we see some of the elements and their symbols and the number of protons, electrons and neutrons. The first one is carbon. The symbol of carbon is C. The atomic number is 6 and the mass number is 12. So the number of protons is 6, electrons 6 and the neutron also 6. Beryllium, Be, the atomic number is 4 and the mass number is 9. So there are number of proton 4, electron 4 and neutron 5. Nitrogen, atomic number is 7 and the mass number is 14. So the number of proton 7, electron 7 and the neutron also 7. Boron, the symbol is B, atomic number is 5 and the mass number is 11. So then proton 5, electron 5 and the neutron is 6. Now we see about isotopes. Atoms of a same element can have different number of neutrons. Such atoms will have same atomic number but a different mass number. These atoms are called isotopes. For example, hydrogen has 3 isotopes. Hydrogen has 3 isotopes. Hydrogen, that is the mass number is 1, the atomic number also 1. In deuterium, the atomic number 1 but the mass number is 2. In tritium, the atomic number is 1 and the mass number is 3. Next one is isobar, atoms that have the same mass number but a different atomic number, that is called as the isobars. Here argon, potassium, calcium, these are having the mass number 40 but the atomic number is varied. Argon has 18, potassium has 19 and calcium has 20. Now we see the elements and their symbols with their atomic number and mass number. So the first one, hydrogen, the symbol is capital H, atomic number 1, proton 1, neutron, there is no neutron, mass number is 1. Helium, symbol of the helium is capital H, small e, atomic number 2, protons 2, neutrons 2, mass number is 4. Aluminium, symbol is capital A, small l, atomic number is 13, proton 13, neutron 14, and the mass number is 27. Oxygen, capital O, atomic number is 8, proton 8, neutron 8, and mass number is 16. Sodium, capital N, small a, atomic number 11, protons 11, neutrons 12, and the mass number is 23. Now we see about the valency. Valency is defined as the combining capacity of an element. Atoms of different elements combine with each other to form molecules. Valency determines the number of atoms of an element that combines with atom or atom of another type. Understanding the valency by an example, imagine there are various people having different pattern of hands. Some have no hands and some have one, some two and others three. Few have four and no one has more than four. The person with the four hands can hold hands of four others at the same time, while the one with no hands can never hold any hand. In this manner, some atoms can hold one electron, some can hold two, some can hold three, some can hold four, and some cannot hold any electron. This property is called valency. The combining property of an atom is called as valency. It is a measure of how many hydrogen atoms it can combine with. For example, oxygen can combine with two hydrogen atoms and create water molecule. The valency of oxygen atom is 2. In case of chlorine, it can combine with only one hydrogen and to create hydrochloric acid. Here the valency of chlorine is 1. In methane, methane has one carbon atom that combining with the 4 hydrogen atoms to form carbon molecule is methane. Can you guess the valency of carbon in methane? Yes, the valency of methane is 4. In ammonia molecule, nitrogen combines with the 3 hydrogen atoms. So what is the valency of nitrogen in ammonia? The valency of nitrogen in ammonia is 3. Valency is defined as the combining capacity of an element. Atoms of different elements combine with each other to form molecule. Valency determines the number of atoms of an element that combines with atom or atoms of another type. The element having valency 1 is called monovalent. For example, hydrogen and sodium. The elements having valency 2, that is called as divalent. Example for divalent is oxygen and beryllium. If the elements having valency 3 means that is called as trivalent. The example for trivalent is nitrogen and aluminum. Some elements exhibits more than one valency. For example, iron combined with oxygen to form 2 types of ferrous oxides and ferric oxide. However, we will study about them later. When atoms of different elements combine with each other, then the molecule of compounds are formed. In these instances, it is necessary to know the valencies of those elements. For example, sodium chloride, valency of sodium chloride, valency of sodium is 1 and the valency of chloride also 1. Here the valencies of both sodium and chlorine are 1. So the valency of element sodium is 1 and the valency of the element chlorine is also 1. Then the molecular formula will be symbol of elements is sodium chloride. So the sodium also 1 and the chlorine also 1. Now we see the elements and their symbols with their atomic number and mass number and valency. The first one is hydrogen. The symbol is capital H. The atomic number is 1. Mass number is 1. The valency is also 1. Carbon. The symbol of carbon is capital C. Atomic number 6. Mass number 12. Valency of the carbon is 4. Oxygen. The symbol of oxygen is capital O. Atomic number 8, mass number 16, and the valency of oxygen is 2. Sodium, symbol of sodium is capital N and small a. Atomic number 11, mass number 23, and the valency of sodium is 1. Calcium, symbol of calcium, that is capital C and small a. Atomic number 20, mass number 40, the valency of calcium is 2. Thank you, students.